polynomials, how to design a polynomial and things using in a MATLAB. So I'll first of all share my screen. Yeah. So we'll basically outline is like this. What is polynomial? What is the way we need to look into the MATLAB? And what does that polyval function does it? How to determine the roots of this polynomial? How to do the addition, subtraction, multiplication, division of the polynomial? There are certain formulas for it or functions already inbuilt into the MATLAB. Then derivatives of the function, and then we'll have a conclusion. So first of all, we'll look at it. What does that polynomial means? It is in a function. It is only one single independent variable function, that is a x here. F is a function, a0 plus a1x plus a2x square and all these things. a0, a1, a2 are all our coefficients, and this function is all the time it is equal to 0. So make sure that this is equal to 0. So accordingly you need to bring all the parameters on one side and kept rest of the parameters on right side. Then similar fashion you can have on a different polynomial. This is a general definition of the polynomial. This can be used for many places, for curve fitting purpose, may be used for interpolation purpose, or so many other places also. And here we can see in a few examples of the polynomial. One is fifth order polynomial, second order polynomial. First order polynomial is typically a linear equation, straight line I can say it. So we'll now look at how to have this polynomial into MATLAB. So we know that in MATLAB, whenever we are going to write anything, we are converting into the matrix language. So here you can have a function called as a polyval, and whenever you have a function like 8x plus 5u, you need to concentrate on one thing. It is x is my variable, and power of x matters a lot out here. So if power of x is 1, then I have to have two numbers into that particular array. That is 8 is one number and another is 5. Then if you look into the second order polynomial here, so it is a coefficient is 2. So that's what it is written 2. Then minus 4, it is written as a minus 4. 10 as a constant, that is as a 10. So similarly, if you look into the third equation, that is cx square minus 150. So you need to just drop down the power of each element. Here it is starting with an x0, x raised to 2, x raised to 1 and x raised to 0 like this. So here it is 3 elements will come. First is x raised to 2 has a coefficient 2, x raised to 1 has a coefficient 0, because here it is 0 is a coefficient, and I can say it is a plus 0 x raised to 0 like this. I can write it. So this whole terms comes to be 0 anyway. So here it is not a 0, it is 1. It should be 1, not a. And this is again multiply with an x raised to 0. It is like this. Yeah. X raised to 0. Yeah. So this is the way we can now define any kind of any higher order polynomial. It is not restricted to how much amount of size of the polynomial should be there. You can define nth order polynomial, maybe 10 order, 20 order, any higher order polynomial. Similarly, you can look at how to define this too. It's the same concept is applied out here. And then when you want to determine a value of the polynomial at particular value of the x, so this is the function is mostly used, that is what polyval. So in polyval we need to supply two arguments. One argument is a coefficient of the polynomial. Another argument is what is the value, at what value of x you want to determine the polynomial. That is x is a number. Okay. So now I will just demonstrate onto the MATLAB. That will be better. So I can now just make it a bigger size. So I want to have a polynomial of second order. So p is equal to, I will now define x square with the coefficient of 1 for 6x, or then I will say it as a 5u Then this is a fourth order polynomial. Now I can write polyval. So polyval into, this is the first one, p is the entire size of the polynomial or definition of the polynomial. I want to determine at value 1.5 something or 1.4 something like this, and when I enter it, so there is a spelling checks. So this happens poly, it is poly, it should be there, it is going to give me suggestions. Okay, so it gives a value of 16.25 something. So this is what the way we can define polynomial, determine the value of the polynomial into the function. So next part, so now you can have a look on one simple example. Define this polynomial of a fifth order polynomial, calculate value of the polynomial at 9, and then plot the polynomial at 1.5 minus 1.5 to 6.7. That is the range within which you want to determine it. So now you can start creating a function for this or creating a script file. Now I'll go for last time we had a discussion on using a script file. I will not elaborate this. So I will give the example. Then I can have an input. Input is what? Polynomial p. So what is the order of the polynomial? It is a fifth order polynomial. So now I can go on p is equal to, you can give any name of the variable, that is not a matter of it. As it is a polynomial, it will be represented within a p. That's what I written a p. Highest order order coefficient is x raised to 5. Now I can, what is the coefficient for this? 1. Then x raised to 4, what is the coefficient? 12.1. Then x raised to 3, 40.59. Then x raised to 2, 17.015. Then you can have so it is in a minus. Whenever it is a minus, keep a minus as it is. Don't play with if it is a coefficient it says as a minus, give the minus. If it is a plus, you need not to provide a symbol for it. Minus 71.95, and then here you need not to give a plus sign. It is a 35.88. So this is what the way we have defined the polynomial. Then after defining the polynomial, you want to determine polyval into. So first of all, you need to provide p as an input. Here it shows an help for you. So what is the value at which you want to determine? 9. Now it will determine the value at 9.1. So now you want to plot from minus 1.5 to 6.7. So what is to be done? Obviously I need to create an array of this entire stuff. So for this purpose, what we can do it, we need to create an array for it. I can have an array is equal to x equal to, so last number is 1.5 minimum number, and then I can have a certain step size, and step size I can have maybe 0.1, then I can go for 6.7. So this is the array it has created. Once I create the array, then I can now again use a polyval as a function, polyval p. Then I will supply this x entire array for it, and it will give me a value as an y as an out. I need to store it somewhere. So then I can have a figure. I can give figure number, or if I don't give the figure, every time it will create another figure. So figure 1, then I can have a plot x versus y. Then I can give an x label, then x coordinate like this you can write, and y label. Then I can write function value, then grid on something. Now you can save this file and run this file. So polynomial, I'll give the name as 01 and I will run it. Once you run, it will now determine the values of, you can just look at here. So what it has done it. Initially it is started with a polynomial function, then it has determined polynomial value at 0.9, that is 9 point something. It has we created an x variable, then it has created values for y from minus 1 point what are the value to the finally 6.7 something. It has created total 83 numbers, and it is now you can just look at the plot of it. So this is the way you can use this polynomial for evaluation purpose. So this is a very simple and easy function for it. Similarly, whenever you want to determine the roots of it, so we know the roots of this quadratic equation, it's quite easily we can determine it as a formula for it. That is x12 is equal to minus b plus or minus b square minus the square root of b square minus 4ac divided by 2a. But in higher order polynomial, such type of formula is not existing. So that's what they use in some routine kind of calculations or numerical technique they use it. So here we will now use this roots as a function. This roots of the function, what it does, it will take in a polynomial, determine what are the roots it has it. So if I have only first order equation, maybe in a straight line, it will pass through only once through it will touch to the x-axis. Means the value of the function is 0 and only once in the linear equation. If I have a higher order polynomial, like just taken a previous example, this is a fifth order polynomial. Obviously, it will touch to the x-axis 5 times. That's what 1, 2, 3, 4, 5. And this is what is the value of x. That is what we need to determine. That is what it is called as roots of polynomial. So we'll again go back to the function. So then I can have a same. I'll write here roots of polynomial. Then I can use simply roots. I can say r is equal to roots of, and we need to provide a p as a vector into this. It has a fifth order polynomial, so it will go on doing it, and it will directly display the values of roots here. You can just look at the graph, and you will come to know. So these roots are the same. Here it starts with 0. It is somewhere 6.5. This is one root. Then it comes back here at this is 4 point something. Then it has come to the 2.3 something. Then minus 1.2 somewhere, and similarly 0.5 something. So this way it has determined 5 roots of this. So once we done this roots, then we'll move next it determine another one. So if you know the roots and you want to construct the polynomial, that is what the way you want to do it. So most of the time what it happens, we may be knowing the roots of equation, but we don't know what will be the polynomial for it. There is one function, poly as a function. You need to supply the roots into this and we can get it. So we'll now do the reverse calculation. So we know the now roots of this. So then I will now roots to polynomial. So now I'll write here PP as a polynomial which we are going to construct it. I will first of all suppress the output wherever it is possible, all the places. Then I will say it is in a poly. I will supply the same roots into this equation and we'll see so whether we get in the same coefficient of the polynomial or not. Then I will keep this window here and then run it. See, so same roots we have started 1, minus 12.1, 40.59, then 17.05, 71 and 35. So these are the coefficient we got it, 6 coefficient for the fifth order polynomial. So this is what the way you can use in a roots to determine the polynomial or polynomial to determine the roots. So then another part is how to use this addition and subtraction of the polynomial. So most of the time we may need in a mathematical operations like subtraction of the polynomial addition of the polynomial. Two polynomials is to be added, multiplied, subtracted. So many operations we need to do it. In that case, what is to be done? This is nothing but a coefficients. Coefficient is thus. So once we know the coefficient, you can now correlate with another one and you can add it up. So here I will now define two polynomials. Okay, I'll just delete all this. So I'll define one polynomial as in a p is equal to 1, 1, 2, 3 as in a, that is a x square plus 2x plus 3. So this is one polynomial. I'll give the name as in a p1. Then p2, which is equal to then 1, that is a 3x square plus 5x plus 10 something. Then I want to add this. So now I can have a p is equal to, I can say p1 plus p2. So simply because both have a same size of the polynomial, that's what I can directly add it up. And then I can have a polyval. Then I can have a pp and I'll determine at 5 something. Okay. So you can just look at the output, how it does, how it gives an output. So this is our first polynomial, then second polynomial, then addition of this. You can just look at this is added to this, 2 is added to 3, so 3 is added to 10 and it gives in a 30. So this is the way you can go on adding, and if you want to have a subtraction, you just remove the subtraction and you can quite easily do the subtraction. But when a polynomial of different order comes and you want to add it up, then comes up in a problem. So what is the problem? Problem is that it is a simple problem. It's not in any kind of a difficulty into this. So P1 here function, you can look at it, has a 6th order polynomial and this is a 3rd order polynomial. In 6th order polynomial we need a totally 7 coefficients, and 3rd order polynomial you need 4 coefficients. Okay, so now you can go on adding this and you can construct it. Now I will have a first polynomial I will write. Then first polynomial, just you can, so first coefficient is 3, then 15, so then fourth is 0, minus 10, then minus 3, then 15, and then 40. How many elements we created? Altogether these should be in a 6th order polynomial, 7 elements. 1, 2, 3, 4, 5, 6, 7. So similar fashion you can have a 4th order polynomial, 3, that is 0, then minus 2 and minus 6. So now whenever we are going to add up or subtract this, so what will happen? Size of both the matrices is not same. So then we face a difficulty. You can just get in some error here. You can find here. The matrix should be often the same size. So for that purpose, what is to be done? Second polynomial, which is higher, we need to take as an base, and rest of the polynomial we need to construct it. So here we have a 4 element and above we have a 7 element. So I can now have 1, 3. I need to add into this and I need to have this is what the way you can add up, and it will determine like addition, subtraction kind of things. So once we done this, then we'll know addition, subtraction, we have seen it. So sometimes we need to multiply the polynomials. One polynomial is to be multiplied with another and kind of things. So for that purpose, what is to be done? We need to use a function called as a convolution. So this function is mostly used in control kind of applications. Convolution means multiplication of two functions. So same way you can have now two polynomials. You want to have a convolution of it. So what I can do it? I can use pp is equal to convolve, conv. I can have a p1 and this is my second P2. I can go on multiplying both of these functions. So I can now get the multiplication of it, and it will determine the what are the output polynomial. So multiplying 6th order polynomial with a 3rd order polynomial, 6 multiplied by 3, how many elements will be 6 into 3? 6 plus 3, it becomes 9 somewhere, and total element of the final polynomial should be a total 10. So here you can just look at it. Here coefficient of whatever the multiplied polynomials are total 6 coefficient we got it. So obviously order of the equation is 9. Though here it is matching 6, here it is a 6th, it is 4th, and then multiply, you will get in a total 10 kind of things. Okay. So this is what the way you can do on a convolution, and here you can plot it, and you can just study it very nicely. This is a mathematics is very interesting, I can tell you. So I will just zoom it, or I will make it bigger one. So this is my first function, that is a second order equation. Then second function, that is a second order, and second function is a straight line. So you can just look at the straight line. When I multiply these two, I'll get in another curve that is a red color indicates. So multiplication will lead to this type of curve. So that is what understanding and meaning of it we can quite easily see through it. Then we'll now look at the division of the polynomial, how to divide this. Convolution gives me multiplication, and deconvolution gives me a subtraction or division. So I can write now deconvolution, and then I will run it. So you can just look at the deconvolution, division of it. So this entire elements, for only how many elements we got? 1, 2, 3 and 4 elements we got as an output. Deconvolution. Because this is the 6th order, then this is the 4th, 6 minus 4, and we'll get in a total 3rd order equation out of it. That is what the way we can understand through it. Okay. So deconvolution, also you can just look at the bigger picture of this. This is the first equation. I will just make it one, send it to, bring it to the front. Okay. So here, so one equation you can get in a curve, that is second order, then straight line. When you multiply both, divide both of these equations, you get in a third equation in this fashion. So you can see an understanding of multiplication, division of these all functions, and this will be much more helpful in mathematical calculations. Last part of it is the derivative. So determining the derivative means if you are having a polynomial of 4th order, you are taking a derivative will be of only 3rd order. So that is the same concept is used out here for analysis purpose. So here then we can have 3 different type of functions we can opt for it. So one is polyder, and only the differences in this case is input parameter. The rest of the things is same. If I say k is equal to polyder p, so I can have now a derivative of a single polynomial with p as a vector and coefficient of polynomial with a vector with a coefficient, and k is a vector, that coefficient of that derivative of that particular polynomial. Another one, polyder, you are going to supply 2 arguments into this. Then obviously it will do a multiplication, product of these 2 polynomials, and product of derivative it will determine. That's what it is, derivative of product of 2 polynomials, that is a and b, 2 vectors, and k will be a product of derivative of polynomials a and b. So similarly you can derivative of coefficient of 2 polynomials, that is uv, and uv are vectors with coefficient of numerator and denominator polynomial. Here it gives in a division of it. So when you are having a 1 polynomial and division of it, n and d are vectors with coefficients of numerator as well as denominator polynomials in the quotient, that is the derivative. So we'll now work out one simple example for it, and you can just look at these 2 functions. f1 function 3x square minus 2x plus 4, and second function x square plus 5, and this is what are the two things we can get. We can multiply these two and you will get a derivative. So derivative of the first multiplied by second, that is what it is going to show it. Okay, so we'll work out into the MATLAB command window. So here we have defined under two functions. First of all, we need to define these two functions into the matrix array. We need to define first of all 3 minus 2 and 4. Second function is again x square 1 0. Sorry. Then here it is in a 1 0 1 0 and then 5. Then I can have a polyder. Then I can have only one polynomial. I will supply and I will see. So derivative of that is how much. So you can just see it, 3 into 2, 6 x minus 2 will be the derivative of this function. So that is what on a straight line. You can just look at here, 6x minus 2 is derivative of it. So you can just even plot it with this, what on a very interesting part. So I can have a figure, then I can have a plot. So first of all, I need to create an x as a vector, x equal to minus 5u to 0.1, 5u, okay. Then I can have a plot, x versus polyval. What is the polynomial? P1 is my polynomial. Then second is pp is vector, polyval as in a pp as in another one, but I need to provide x-axis here also. Then I will close down and I will say it is a grid on. So you can just plot and you can just see it. So there are some input arguments, not enough input arguments, just only. So polyval even. Okay. So I will separately calculate this. Y is equal to polyval into P1, then dy is equal to polyval into pp. That is what in two functions. So whenever we are going to debug it, so make sure that up to this which we have done in modifications, I want to check it whether this much code is perfect or not. So then I will put up a written, so that I will come to know where the error lies. So the error is obviously it is showing at this point. So it is showing the error not at this line, but it is showing somewhere in another function. So there is a where you have an error here. So I need to give an input argument as an x here as well as here x here. We are missing it. So now I can have here, I can write y here and I can have a dy here, and I will remove the written here and I will plot it. You can see it here. This is my second order equation, and second order, if you are taking a derivative of it, it will come into a straight line. That is what in a simple you can do it. So similarly, if you have two polynomials like this and you want to multiply this, or you want to give a multiply and take a derivative of it, so I can have a p1 p2, I will provide it input, and then I will have one more y z is equal to polyval p2, so I'll write p2 x, okay. Then one more plot I need to do it here. Here I will change it to the chat. So you can just look at how this varies. One is straight line, second is in a multiplication, use me, so I can't understand which color is this, so I can use in the legend here. So I can have an x, then y, sorry it is a z, So here it is in a y, z, and then I will have in a dy. Then you can just look at what are the colors for it. So I need to provide a balance of the function. So that's created multiple files. Okay. So here red color indicates derivative of it. Multiplication of second order polynomial with another second order polynomial gives me second plus second, it gives 2 into 2, it gives fourth order, and derivative of both the particular, that gives in a third order polynomial. So shape is same, no issues. This is what in a third order polynomial you can get quite easily. So this is the way you can do an derivative determination and so many things. You can try on these functions. So here this is what the d and n you can determine, and you can play with it. Lot many things you can learn through it. So this is all for today's session, and we'll stop it here.